Hey everyone, welcome to our new unit on radical and rational functions for Math 30-1. And our first lesson today in the workbook is going to be on radical functions. And we're actually going to do lesson 1 and lesson 2, which is completely on radical functions. First of all, we're going to look at a radical function and the transformations of that and how it affects domain and range. So radical function, what is it, right? Well, the simplest radical function there is this one, y equals the square root of x, okay? What we're going to do is we're going to analyze the graph of that, and then we're going to look at the transformations of it. So really a radical function is just a function that has the variable underneath the radical sign. Okay, and you could have cube root, but we're just going to deal with square root. All right, let's look at the graph. So to sketch the graph, we're going to complete this table of values, and just remember that y is equal to the square root of x. So each of these x values would get subbed in, we find the y value. So let's try the first one, square root and sub in -4. Square root -4, if you want to try it on the calculator you can, but in essence, in the real number system, you can't square root a negative number. So that one would be does not exist, okay? In other words, at x equals -4, the graph will not exist. Try -1, same situation. Okay, I'm going to abbreviate that to DNE, does not exist, okay? Alright, and then if we put in 0, so square root of 0, you can confirm with the calculator if you want, but really we're looking for a number that when we square it, we get 0, and that would be 0. So, square root of 0 is 0. Okay, 1, if we square 1, we get 1, so therefore the square root would be 1. Okay, 4 is the square of 2, so the square root of 4 would be 2. And then 3, and then square root of 16, 4. Good. Okay, we're going to sketch those points. Can't really plot anything for -4 and -1, so we'll start with 0, 0, put that on the graph. 1, 1, 4, 2, and 9, 3, and 16, 4. Okay, and then we'll try and draw a fairly smooth curve through those points and label it y equals the square root of x. Awesome. Okay, that is essentially what a radical function graph looks like, the base one, a very basic one. Okay, let's talk about the first one. Explain why the domain of the function y equals root x is not a set of real numbers. So in other words, why is it not possible for all real numbers? It's because you cannot square root a negative number in the real number system. Okay, so in other words, what would our domain be? State the domain. X has to be greater than or equal to 0. That was our lowest x value. And you can write the domain like that. You can do it in set builder notation, which looks like this. And you tack on x and l in the reals to state that we have every single point on this continuous line that's greater than 0 or equal to. Or you can do interval notation. Okay, interval notation would be, we have to include 0, so 0 to, really it goes forever, so infinity. Left boundary of our domain, right boundary of our domain, okay? All right, let's look at range. So, looking at our graph, range, y values, looks like all possible y values start at 0 and then continue up. So, same idea, y has to be greater than or equal to 0. And again, you could write that with set builder notation or interval notation, okay? Either one. All right, really you just have to be able to recognize the right domain for the diploma, right? And for my exam as well, we'll have, I will take any of these ways of writing domain and range. Okay, let's look at the next page. So we're looking at transforming the radical function. So all those transformations you learned in the transformation unit apply now to the radical function. So we have translations, which is moving it up and down, left and right, and that's to do with x and to do with y. Reflection in the x and the y axes. So if y goes negative, we reflect over the x axis. If x goes negative, we reflect over the y axis. And if you switch x and y, we get a inverse function, which is a reflection in the line y equals x. And then we have our stretches. Vertical stretch is replacing y with something, and therefore you would reciprocal that to get the stretch factor. Or stretching horizontally, x is replaced with something. And really the stretches is when you're multiplying your variable by a number, and the translations is when you're adding or subtracting. Reflections occur when you multiply x or y by a negative number. Okay? And as before, in order to build the equation, the order in which we do transformations is stretch, reflect, translate, or think of the word sorted out. Stretch, reflect, translate. All right, good. Let's take a look at example 1. Okay, in each case, okay, so there's 4 parts to this, I believe. And our first one is this equation, y minus 4 equals the root of x plus 2. We are going to describe the series of transformations, and when you do that, you have to do it in the order of stretch, reflect, translate to get this given graph. So let's take a look at the transformations. Okay, so we don't have anything being multiplied by x or y, so there's no stretches. There's no negatives being multiplied by x or y, and x and y haven't switched, so no reflections. So we just simply have some translations. The x was replaced with x plus 2, so therefore it moved left 2, and the y was replaced with y minus 4, so again, opposite of what you think, it would move up 4. All right, there's our transformations. Rough sketch. Really, if we start with this as our original graph, the key point we want to translate would be 0, 0. So if we move 0, 0, left 2 and up 4, label where that would be, negative 2, comma 4, and then draw a graph that's similar in shape. That would be our transformed graph. There we go. Domain and range. Let's take a look at that. Okay, so our domain, if you look, really we have no x values left of negative 2. So really our domain x values start at negative 2 and then continue to the right. How would we write that? X is greater than or equal to negative 2. Whichever form you want to write that in, I'm fine with. Range, we're talking all possible y values, so we look and we have no y values down here, but they start at 4 and continue forever up. So y would have to be greater than or equal to 4. Okay, let's take a look at the next example. Oh wait, we're not done with this one, are we? Yep, no, we just have to graph it on the graphing calculator, and that will be fine. Okay, so we'll look at the next example now. Okay, so for the next one, we have 2y equals the square root of negative x, and we're comparing it to our base function, which is y equals root x. So y looks like it was replaced with 2y, so we do have a stretch, but since it's with y, it would be a vertical stretch by a factor of, and we always reciprocal the number in front of the letter, so it would be 1/2. When we wouldn't is if that 2 is in front of the whole function and therefore not with the y, then it would be a vertical stretch by a factor of 2 if it was over here in front of the function. Okay, so by a factor of 1/2 about the x-axis. Okay, horizontal stretch? No, but we have a negative in front of the x, so that's going to be a reflection. And let's see, if x goes negative, we would be going, let's see, over the y-axis. So reflection over the y-axis. Okay, good. And that looks like all we have. So let's do that to our graph, and then we'll figure out domain and range. So reflection, or first, vertical stretch by factor of 1/2. Now what that means, let's first look at 0, 0. If we stretch that vertically about the x-axis, it's not going anywhere because it's on the x-axis, so it won't move anywhere. However, a point, say here, however far it is away from the x-axis, that distance would be half of what it was of original. So in other words, it would end up looking something like this. Well, maybe that's not quite half. Hopefully you can draw it better than I can. And there we go, something like that. Okay, and then reflect over the y-axis. So here's our y-axis. If we reflect over the y-axis, that's going to end up looking like this. And that would be our final transformed function of 2y equals square root of negative x. Now, we can confirm that on the calculator by isolating y, divide both sides by 2 so that we have a 1/2 and then square root of negative x. So let's just check that out on the calculator a minute and see if we get that same function. Okie dokie. Here's our calculator. And we are graphing in y equals, we are graphing, what was it, y equals 1/2, so 0.5, square root of negative x. There we go, enter bracket, zoom standard, and look at that, there's our graph. Good job, okay, that looks very similar to what we have. So that means we've got the right graph. Let's do our domain and range. Okay, so domain this time, if we're looking at the x values that would occur on this graph, nothing really right of 0 happens, so only less than or equal to 0. Okay, for y values, again, as we kind of slide from bottom to top, you'll notice the first y value we hit is 0, and then it keeps going up. Now, it's not very steep, but it does keep continuing up, and therefore y would be greater than or equal to 0. All right, good job. We checked it with the graphing calculator. Okay, why don't you guys try the next two? Write down the transformations, sketch the graph, and then determine the domain and range. And we will check back in a minute to see if we have the same answer. Okay? Pause your video, please. Okay, how did those go? Let's check over C. So C, first we have a negative, so reflection over the x-axis, and then we have y plus 5, which means down 5. So if you do the transformations to the graph in that order, we would reflect over the x-axis, then move the graph down 5, and we'd end up with this red graph here. Looking at that graph to find domain and range, x would be greater than or equal to 0, and y would be less than or equal to negative 5. This time we're going down from that key point, so that's why y is now less than or equal to negative 5 instead of greater than. All right, D, a little bit tricky. I don't know if you caught this, but from the transformations unit, do you recall that if we have a number immediately in front of x, we have to factor that out in order to determine our horizontal translation, our proper horizontal translation. So if we do that, we factor it out, not outside the square root, just away from the x a little bit by putting brackets. So 2 bracket x minus 1/2. So we factor it out by dividing 1 by 2. So 2 is still with the x. It always remains with the x. Y, the stretch factor for y, however, there's nothing in front of the y. It's over here on this side. And as a result, that 3 is literally our stretch factor because it's not with the y. The 2 is with the x, so we have to flip that to get our stretch factor of 1/2 horizontally. Okay, then translation right 1/2 because it's x minus 1/2. So if we do that to our graph, first of all, I did the vertical stretch by a factor of 3, so all these y values basically became 3 times what they were, the key point still at 0, 0. And then horizontally stretched by a factor 1/2, so all the x values became half of what they were, giving us the green graph, and then finally move it to the right 1/2, which would give us the red graph. Domain x greater than or equal to 1/2, and range y is greater than or equal to 0. Awesome. Let's look at our last example. Okay, we're going to determine the domain and range of each of these, given that a and b are either positive or negative. So we're really talking reflections. A is your reflection over the x-axis, and b, if it's negative, reflects over the y-axis. Okay, so on the first one here, oh, and what's our domain and range normally? Well, our basic graph looks like that. So domain would be greater than or equal to 0, and range would be greater than or equal to 0. So for the first one, where they're both positive, that's our domain and range. Greater than or equal to 0 for x, and greater than or equal to 0 for y. Okay, I want you guys to take a stab at what you think B, C, and D would be for domain and range. Do a little sketch if it helps, okay, to kind of see what it looks like, and then we will check back and see if we have the same answer. Okay, pause your video, please. Okay, welcome back. We are running out of time, so I'll run through this quickly. B reflects over the x-axis, gives us this graph, and that would change y to less than or equal to 0. C, reflect over the y-axis, changing domain to x less than or equal to 0. And then finally D, reflects over both, so both, sorry, messed up on this one, both are less than or equal to 0 for our domain and range. See you in part 2.